Wilson Audio's been around for 50 years, and we've invested a lot in the different processes here. Perfection's impossible, but excellence is within our reach, is what my dad used to say. We do a lot of things in-house, and that's a little bit unusual in the industry because there are a lot of companies that manufacture loudspeakers, but there are pieces that are shipped in. Crossovers are fascinating. We could have those OEM'd. We could have a company make them within a tolerance of 1 to 2%. What we decided to do was invest in manufacturing our own capacitors. We bought 2 machines recently, and they're manufacturing capacitors instead of having to do a bundle where it has several solder joints and it introduces certain small amounts, but still parasitics into the signal path. We're able to wind down to the tolerances that we want in the construction and the material that we specify, down to tighter tolerances than we've ever had before. But when you start manufacturing, you realize the sky's the limit. No one's telling you where you need to stop and what the limitation of the types of materials you're using or what you can and can't do. So our crossovers being hand-built point-to-point connections here in-house, we make our own capacitors, and now we make our own inductors.
So now we have the ability to make our own inductors. And as we've looked at this process, the question came up, how can we make it better? Of course, a standard inductor is a wire wrapped around either some form of a bobbin or in the air. That gives you the characteristic of an inductor. But how can you make it better? One of the things that we've looked at is how it's wound, what the lay, and by lay, it's how the wires are over the top of each other. Also, what types of wire is it comprised of? Not just copper, but how many pieces of copper. So it can be a wire that's got multi-strands. It can be a wire maybe with a different metallurgy. Those types of things start the process of making it better. But then you have to go into its construction. What types of construction make it better? Do we change one dimension? Do we change 2 dimensions? Ultimately, how that electric and magnetic fields interact in that construction will then impose itself upon the sonic qualities in the crossover and ultimately in what people hear. And so that's the concept of trying to make it better. After we've changed the construction, you have to listen to it. It has to be an audible positive change. I can mathematically look at something and make it a positive, but what does it sound like? And if we can't make it sound good, then it's no good.
You think about the hands that go into crafting a Wilson Audio product. We talked about how we wind and then hand finish the capacitors. We're winding and hand finishing the inductors, and then when it's all hand assembled and soldered, we put those crossovers. Putting the crossover, it solidifies the components in the crossover relative to each other, so they're not vibrating close to each other, which introduces crosstalk and other kinds of things that create technically distortion. So to get a cleaner signal path, potting really has served us well. And so when you see a Wilson Audio crossover and you see it's in this hardened black goop, there's a reason behind that. It's not just for the sake of not showing people what the crossover looks like. There are sonic benefits in doing so. There's a lot of engineering and science that goes behind making a Wilson Audio product, and every designer has their own checklist of what's important to them. And we have our own checklist, and not everyone understands that checklist. Getting to the end of developing a product and listening to music, and when you hear that music deeper and clearer and more emotionally, your body responds emotionally to it. That's the why. That's what we do. Connect people with their music in the deepest way possible. All the while, in my opinion, making something very beautiful.